We're now ready to start talking about circles. There's quite a bit about circles, just like there's quite a bit about right triangles in geometry. We'll start very simple. The things that you know, we'll put some different definitions and some formal definitions with them so you can get started with this. First topic we want to talk about is circles and circumference. Definition of a circle. Circle is a locus, locus meaning a collection. Okay, so it's a collection of all points in a plane, or on a plane, that are a given distance, that's being the radius, from a given point or the center. Say it quite rapidly. Circle is the locus or collection of all points in a plane that are a given distance, the radius, from a given point or center. This is also Euclid's third postulate, his third law, third axiom, which we build our geometry. Now, a radius, okay, is a segment with endpoints. Spell that right. Get this a little better here. Endpoints at the center of a circle and on the circle. So radius is a segment with endpoints at the center of the circle and on the circle. So one endpoint is always at the center, other endpoint is on the circle somewhere. A chord is a segment with endpoints on the circle. Okay? Its endpoints are on the actual circle, or on that collection of points. Diameter is a chord that contains the center of the circle, or a chord that goes through the center of the circle. So those are our main definitions. We'll get rid of this and draw some things and let you actually see them. Those are the definitions of the terms we're going to be using, or major terms we're going to be using. There'll be some more, but those are the major ones. A few other things about circles. Here, we've drawn one here. Here's a circle. Let's describe it. The center is A. Radii, or radius, several radius. AC would be a radii, starts at the center, goes to the edge. AB would be another radii. AD would be another radii, okay? Because all of those have endpoints at the center and on the circle. Point here, AC and AB are collinear radii that make up the diameter BC. Okay? They're on the same line, okay? And they're collinear radii that would make up the diameter BC. Chords, okay, segments with endpoints on the circle, RS, okay, have points on the circle. They have endpoints on the circle. Okay, that's a chord. Now, BC is also a chord. Okay, why? Because it has endpoints on the circle. It is also the diameter. Why? Because it contains the center. Remember, the diameter is a chord that contains the center or goes through the center. Circles are named for their centers. So this one would be circle A. This is how it's written. So anytime you see that, you know it's circle, and the letter after it will be the center. There are some equations, just one basic, and we derive another one. The equations, the diameter equals 2 times the radius, or D equals 2R. When we solve this equation for R, we get R equals D divided by 2. So those are a couple of equations you're going to want to know. They should be on your formula chart. Now let's go into circumference. Let's talk a little bit about circumference. That's the other thing about circles. Circumference is the distance around a circle. That's the definition. We could also call it the perimeter of a circle. You're familiar with that term. Perimeter meaning the distance around a polygon. Okay, adding all the sides of a polygon together. So the perimeter of a circle, the distance around a circle, the perimeter of a circle. We have a couple of equations for that, where C equals pi d. What does C stand for? It stands for circumference. D stands for diameter, R stands for radius, and pi stands for, that symbol here stands for pi, Greek letter used to represent the ratio of circumference divided by diameter, or 3.14159 ... is a never-ending number. Okay, computers have calculated out to the billions of decimals and never have repeated. Now, I say the ratio of c divided by d. Well, obviously it is. Okay, cannot use c divided by d as its representation because it is a number. It represents a number. You take any circle's circumference, you divide it by its diameter, you will get the number pi. It just is. It's the way the universe was created. We didn't make it. We didn't create it. We didn't dream it up. We discovered it, discovered that ratio, and we get to use it. It's one of those things that happens in creation is we get to discover how it's put together, and then we get to use those discoveries in order to learn more about our creation and learn more about what's out there in the universe. One of those unique kinds of things. So, pi is a constant. We like to say it is 3.14159 blah 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 blah. No, it is a ratio of the circumference and the diameter of a circle. Any circle. It doesn't matter how big the circle is, doesn't matter how small the circle is. If you draw a circle around an atom, or the nucleus of an atom, and you take its circumference, divide it by its diameter, you're going to get pi. We're going to draw a circle around the universe, measure its circumference, divide it by its diameter, you would get pi. That's how constant it is. Now, for your calculations in high school and on and beyond, it's best to use the pi button on your calculator. It's usually a second or third button, third function button. You need to locate that. It will put the symbol pi there, and it will use a very long decimal number for that and get you a very accurate calculation. If you use numbers and you want to key it in, you know, in junior high you were told, wow, just use 3.14. That's no longer accurate enough for the calculations you're going to be doing. You need to use 3.14159 at least. Okay? 3.1416 used to be fairly common, but 3.14159 would give you an extremely accurate approximation of what pi is on your equations. All right, circumference of a circle. Now when we use those equations, two forms of it, c equals pi d, or c equals pi times 2r. Well, d equals 2r, as we found out in the last clip, okay? 2 times the radius equals d. But when we use it in this form here, typically you're going to see c equals 2 pi r. Okay, they're going to split that 2 and r up and put it in front, put the 2 in front here because it is a number constant, put it in front. So c equals 2 pi r is a very common one. Also you'll see c equals pi d. Those should, or some form of those should be on your formula chart, geometry formula chart.